All right, so tangential acceleration and tangential velocity in the same direction, we're speeding up. No centripetal acceleration means we're not moving in a circle. Tangential acceleration opposite of our tangential velocity means that we're slowing down, just like always. Still don't have any centripetal acceleration, so we still don't have a circle. If we do have we don't have tangential acceleration, but we do have centripetal acceleration, then that means we're moving in a curved manner. No tangential acceleration, so we're not speeding up, we're not slowing down because there's no tangential. Tangential only affects the speed, centripetal only affects direction. If we have tangential velocity in the same direction, or tangential acceleration in the same direction as our tangential velocity, then we're speeding up. If we also have centripetal acceleration, then we're going around a curve. If the tangential velocity is opposite of our tangential acceleration, then we're slowing down. If we also have centripetal acceleration, then we're moving in a curve. Let me get out of the way here so you can see what's happening with these bar charts down there. It's very interesting and useful. K is going to be our kinetic energy. U is our gravitational potential energy. This looks like a pendulum. One of those things I was telling you about where it's just a mass at the end of a string. Let's see. This is a pendulum pendulum, which is a dense ball called a bob swinging on the end of a string. Note the pendulum speeds up as it moves downward and slows down as it moves up. The velocity vector, gray arrow, is always tangent to the path. The longer the velocity vector, the faster the bob is moving. As the speed changes, there is a tangential acceleration. That's the blue vector, cyan. When the bob is speeding up, the tangential acceleration points in the same direction as velocity. Just covered that like 20 times. When the bob is slowing down, the tangential acceleration, that's right, is opposite of our velocity. Because the bob travels in a semicircular path, there is centripetal acceleration, the red vector. Centripetal acceleration always points towards the center of the circle. Centripetal acceleration increases as speed increases because of the equation. Centripetal acceleration equals v squared over r. So if we're increasing velocity, we're increasing the centripetal acceleration. Two accelerations are components of the full acceleration, the one in the pink. When acceleration makes an acute angle with velocity, the bob is speeding up. When the acceleration makes an obtuse angle with velocity, the bob is slowing down. That kind of makes sense because if our velocity is in the opposite direction of the total acceleration, then we're probably slowing down. If it's in the same direction, then we're probably speeding up.